Hi guys, welcome back to Velotio Tech Shots. I'm Ishan Khanduja. I'm working as a lead software engineer with Velotio and hold over 8 years of expertise in building backend applications. Today we are going to look at a module called clusters and how clusters can help us improving Node.js application performance. By the end of this video, you will have proper understanding of clusters, how clusters work, the advantages, and how we will be using it. Then we will have a look at some performance metrics comparison using load test and followed by a few of the downsides of using cluster. We all know Node.js is a single-threaded programming framework, which is very memory efficient as it makes use of event loop and live-UV module to handle concurrent requests. How clusters can help us? Node.js being a single-threaded cannot leverage the resources efficiently, as we have different configurations of machines available physical or virtual like dual-core, quad-core, octa-core, or more processors. Clusters can help us deploy each of the process in each of the core present in the machine, hence making it a bit performant. Here is how it works. So master process, depending on the number of cores present, spawns the child process. Every process has its own event loop, memory, and V8 instance. Now imagine how fast it could become. The master process listens for incoming request at a port and it distributes the request to the child processes in a round robin fashion. Communication between master and child process happens through IPC, that's inter-process communication. All processes in the clusters can share the same server port. This is important. So our master process will be listening for all the requests in a single port, and this master process will be responsible for distributing it towards all the child process. And hence, we are using only one port in this case. What are the advantages of using cluster? Clusters comes as an inbuilt module for Node.js, and hence it is very easy to set up. If there is a long running or blocking operation in one of the workers, then Node.js or master process can deviate the other request coming to different process present. And also we can make change to our application without some downtime. So let's say if I want to deploy some new changes, then I can restart my child processes one at a time. And hence we can see like little to no downtime in deploying the new changes. And also, yes, it enhances performance as it divides the load between the worker process. Use case. You must have heard of the module called PM2, that is Production Process Manager. Production Process Manager, in case of Node.js, makes use of cluster to make it bit performance and to increase its throughput. The cluster modules also uses the load can be used as a load balancer to divide the request along multiple child process. This is how we will be using it. So we are here doing nothing but just importing the inbuilt module, and depending on the number of cores present, we are spawning the child processes. Now let's have a look at a small demo with some load testing. So here, as you can see, I have created few scripts. One is making use of clusters and one without cluster. So let's have a look at each of the script. So first, let's have a look at our script with no cluster. So here we are doing nothing but we are just running application on port 9000, and it has just we have just exposed one endpoint which is taking one number as an input, and we are doing nothing but we are just iterating over that number and printing the final counter. So in this script we are not making use of module cluster. Now let's have a look at a script where we are using cluster. So here we are doing the same thing, just the difference is we are now using the module cluster, and we are using it in port 9001. We are checking if it is a master process, and based on the number of cores present, we are doing nothing but we are just forking, or we are just spawning the child process. And in the same, we are doing the same, we are exposing the same endpoint, which is taking one input as a number, and we are looping over it and printing the final counter version. So to test these scripts to check like for how the performance comes into picture with while using clusters and while not using clusters. So we can make a use of a module called load test. So let me open another terminal and let me make sure our load test module is installed. Let me install it globally. So yes, this module is now installed. Now what we will do is we will start our application first without cluster. So we'll do no cluster, Node.js. So we can see now our application is running on port 9000 and we have one API exposed for the counter. So what we can do, we can make use of this load test module. We can pass one number attribute where we can say how many requests we want to make. Also, it comes up with a parameter called concurrency, like how many requests at a time you want to send. So let's make it 100 as well. Now, here is our endpoint, host 9000 counter, and let's give one number. So in this case, it made 100 requests parallelly, and we can see it handled 150 requests per second with a latency of 325. Now let's increase the request. Let's put some real load. So now instead of 100, I'm going to make it 1000 with 100 concurrent requests. With the same number, I can increase the number again so that it will be busy doing the operation. So as you can see now we have increased the throughput. So it's just taking a bit time now. I'll pause the video till the time we can get the result. All right. So this is the result when we have made the when we have run the 1000 requests with some counter. So in a second, it handled 18 requests with a latency of 5171 millisecond, which is huge. Now let's try to replicate the same behavior with our cluster script. So we have stopped the application. Now we'll be running the same. So now as you can see, I have 16 posts present and it started the master process plus 16 worker processing. Now let's try to run the same request using cluster script. So now it is running on port 9001 and we have the same request. We are putting 1000 requests with 100 concurrent requests and with the same counter that we have done for no cluster script. Again, I'll wait for this to complete. All right, this is already done. So as we can see now, the request that it handled per second was 178 compared to what we have seen for the one without cluster was 18. So you can see the difference. And latency in the previous case was 5000 milliseconds, and in this case it is 500 milliseconds. So you can guess the difference that we are getting in the performance wise. So now as we have done the performance metric comparison, now let's move towards the downsides. So now using clusters, different processes are running in different cores or different processors. So now it's developers' responsibility to do a session management between them. And that again comes with some cost of complexity. Sockets IO connection won't work properly. Yes. So let's take an example of a chat application built using clusters. So let's say I'm doing a chat with my friend using my system that is currently, the connection got established on thread 3. Now I want to continue my chat using my phone. And if from phone, if I'm again initiating a connection, it happens that it won't get the same thread. Let's say like it got now connected to thread 4. Now, what will happen is I cannot be able to see the chats that I've been doing with my system. Now, from it seems like I'm again initiating a new chat. So it is again like we have to handle it explicitly to make a connection sticky or with some different other approaches. Updates to shared state in a separate process are not immune to these conditions. So again, this is same as the first point, where like if it is running in different processes and if it is updating the same state, then it's developer responsibility to make appropriate changes to avoid these conditions. Using the debugger can be significantly more complicated, particularly when trying to track activities in several successive requests. So let's say if I want to, if I want to debug some three successive requests, like it may happen like, I can see like the first request is taking bit time, and then second request is getting delayed because of the first one. So I want to debug some successive requests. So it might happen it now won't come into the same process. It might come into the different request might come in different processes, and hence make it a bit difficult to debug. So yeah, these are the downsides, and if you can handle it with some cost of complexity, or if your application is not making use of that socket IOs, then you can go ahead and implement it today. That's it from my end. Thank you for watching. Have a good day.